Hello everyone, welcome to the SQRT channel. In this video I'm going to talk about a problem that I got from a Stanford Math Tournament from 2022. This problem is problem number 6 of the tournament. Here we are going to compute the expression that you are seeing here. In this expression we have cotangent of another expression. For that expression itself we have 2 sigma. Let's talk about what we have inside this sigma. We have 1 plus sigma of 2k for k from 1 to n. And then we are going to take the inverse of cotangent of this expression, and then we are going to compute the sigma for n equal to 1 to 23. After all this, we are going to take the cotangent of the whole expression, and that's something that we are going to compute today. Now let's talk about the solution, but before that, make sure that you play with this problem to understand it better. To solve this problem, I'm going to break it into different pieces. Since the expression itself is large, I'm not going to play with the whole expression at the beginning. Instead, I'm going to try to simplify different pieces of it. Let's focus on what I have here as calculating the sigma of 2k for k is equal to 1 to n. It's obvious that this expression itself is very easy to calculate. Since 2 is a constant number, we can take it out, and then I'm going to have sigma k for k equal to 1 to n, which is n times n plus 1 over 2. And since I have 2 times this expression, it's going to be n times n plus 1. That was easy. Now let's talk about another part of it. I have cotangent of an expression. Let's say that expression itself is s. So at the end, I need to find cotangent of s. But first, I'm going to find what I have for s. To write it, s is going to be sigma n equals to 1 to 23, and then inside the sigma I have the inverse of cotangent of 1 plus n times n plus 1. Now let's focus on this expression that I have for s to try to simplify and find the answer for this. Now I have s, as you see here in the box on top of this slide. I'm going to find it, but to find it is kind of difficult to deal with it directly. So let's focus on what I have here. I have a sigma, and the sigma starts from n equals to 1 to 23. Inside the sigma I have negative cotangent of another expression. I'm thinking to break this negative cotangent into 2 pieces so I can deal with it better. And I remember that I have an identity. Let's review the identity now. If I have negative cotangent of x and negative cotangent of y, I can say that the inverse of cotangent of x plus inverse of cotangent of y is going to be inverse cotangent of xy minus 1 over x plus y. If you are not familiar with this identity, try to prove it. It's not hard to prove. Now based on this, what you are going to see here is inverse cotangent of xy minus 1 over x plus y can be written as 2 separate inverse cotangent. But first, I need to find what I have for x and y here. Obviously, the very first thing that we notice is in the expression that I'm going to calculate, I have 1 plus another thing. But in the identity that I have here, I have xy minus 1. To compensate for this negative 1, I have to do something here. I'm going to start with using negative x instead of x. Now I have inverse cotangent of negative x plus inverse cotangent of y equals to inverse cotangent of negative x times y minus 1 over y minus x. For the top of this fraction that I have on the right hand side, I have negative xy minus 1. I'm going to replace that with negative xy plus 1 and then take out the negative part to the outside of this inverse cotangent. So at the end, for the left hand side, I have inverse cotangent of negative x plus inverse cotangent of y. And for the right hand side, I have negative inverse cotangent of xy plus 1 over y minus x. Now let's take a look at what I have here. For the expression that I need to evaluate, remember we used s for that. Inside the sigma, I have inverse cotangent of 1 plus n times n plus 1. For the final identity, on the other hand, and let's take a look at the right hand side for now, I have negative inverse cotangent of xy plus 1 over y minus x. So I have 1 plus xy, which is something interesting on top of this fraction. For the bottom of this fraction, I have y minus x and I need to get rid of it. But first, let's simplify the whole thing a little bit further and then we will take a look at what we have. So by now, we know that inverse cotangent of negative x is negative inverse cotangent of x. For y, I'm going to use whatever I have and then I'm going to simplify what I have for the whole thing by multiplying both sides by negative 1 and then I will have inverse cotangent of x minus inverse cotangent of y equals to inverse cotangent of xy plus 1 over y minus x. So now note that for the left hand side I have inverse cotangent of x minus inverse cotangent of y, but for the right hand side and for the bottom of the fraction I have y minus x. So that's something that I need to remember. The identity itself is kind of obvious, but we need to remember that what we have for sine of x and y here. So if I want to replace what I have to make it similar to what I have for the expression that we name it as s, I'm going to use n for x and n plus 1 for y. The reason is, if I do so, then y minus x is going to be n plus 1 minus n, which is 1. And I don't need to have anything for the bottom of this fraction. On the other hand, for top of the fraction that I have inside this inverse cotangent, I have 1 plus xy, which is basically 1 plus n times n plus 1. And if you compare the one that we just found and what I have inside the expression that I have for s, you can say that they are now identical. Let's keep it from here and see how we are going to simplify and compute the final expression. If I use whatever I have, you can easily see that s is going to be sigma n equals to 1 to 23, but instead of having just single cotangent negative 1, I'm going to have inverse cotangent of n minus inverse cotangent of n plus 1. And this is going to be the telescoping series. Based on that, I can say that the whole expression, including what I have inside the sigma, is going to be inverse cotangent of 1 minus inverse cotangent of 23 plus 1, which is inverse cotangent of 24. Now we have what we need to have for s. But remember, we didn't find s. We wanted to find cotangent of s. Now, before I continue, I'm going to simplify what I found for s a little bit further. S is inverse cotangent of 1 minus inverse cotangent of 24, and remember, I found that I can rewrite what I have for inverse cotangent of x minus inverse cotangent of y. It can be written as inverse cotangent of 1 plus xy over y minus x. Now here x is 1, y is 24, and I can write the whole thing as inverse cotangent of 25 over 23. With that, remember what I wanted to find was cotangent of s, not just s. And s is inverse cotangent of 25 over 23. So cotangent of s is going to be 25 over 23, and that's our final answer. In this video, I solved a problem from Stanford Math Tournament from 2022. If you would like to see more puzzles, math-involved activities, and problems from other math competitions, please let me know in my Twitter account or in the comment part of this video. Please consider subscribing to this channel, and I hope to see you in the next video.